Welcome to Module 5, 3D Printing Equipment. From sketches to structures, welcome to the setup, where we uncover how 3D printing reshapes the fashion world. We connect printers, materials, environment, and finishing into one reliable system for fashion. You'll learn how additive manufacturing, AM, complements textiles, what choices matter most, how to set up a calm, safe studio, simple routines that prevent failures, and how to decide between in-house printing and outsourcing without guesswork. Here's your map. Methods in plain words, quality as outcomes, safety basics, tidy studio habits, and a simple maker-by guide you can apply this week. Here's where imagination meets utility, exploring how 3D printing finds purpose across fashion's creative and practical worlds. 3D printing complements fabric. It doesn't replace it. It brings structure for closures and trims, texture for raised details, precision for repeatable parts, and jigs that make sewing and assembly faster. The fabric still delivers drape, breathability, and comfort. Together you get controlled geometry without losing movement. Practical fits. A strap receives a printed buckle sized exactly for webbing. A denim square gains a raised pattern aligned with seams. Simple tooling, guides, clips, spacers, keep stitching accurate. The thread count and the print geometry cooperate, so you iterate quickly and reorder consistently. Now, the art of making. The methods that turn innovation into wearable form. 4 families you'll hear. FDM, fused deposition modeling. Extrudes filament. SLA, stereolithography, cures liquid resin for smooth detail. SLS, MJF, selective laser sintering, multi-jet fusion, fuse nylon powder for strong parts. DLS, digital light synthesis, makes high-performance elastomer lattices. We'll use simple language to match each to outcomes. Choose by requirement. Flexibility, elastomers like TPU or DLS, surface detail, SLA, polyjet, material jetting resin, durability, SLS, MJF nylon, or color appearance, dyeable nylon or multi-material jetting. Start with the simplest process that meets the brief. Change only when a hard requirement forces it. Every layer begins with a choice. This is where we explore the elements that give form, feel, and function to 3D printing. With the processes in mind, let's translate material names into how they feel and behave on garments. Translate materials to outcomes. Soft equals TPU, thermoplastic polyurethane, elastomer for stretch and comfort. Smooth equals resin for fine detail and gloss. Strong equals nylon, PA12, PA11, for tough light parts. Showy equals full color jetting or dyed nylon. Think fit for purpose, then select the material family. For FDM on fabric, secure the textile flat. Test adhesion with a small swatch and use TPU for overlays that move with the cloth. Space motifs to preserve drape. Start small, then scale a pattern across panels once adhesion looks clean. Start on swatches, then move to cut panels. If it's for wear, test a small wash. Dye nylon uniformly or in gradients. Paint or clear coat resin for gloss and protection. Tumble SLS for smoothness. Where skin contacts plastic, soften edges, sand, or line with fabric. Gentle finishing elevates parts from prototype to product. With materials mastered, it's time to refine the craft. How quality and orientation shape the final look and feel of every print. Think outcomes. Fit, feel, finish. Then apply the 3 quality levers to reach them. 3 levers move quality most. Stable motion, no wobble. A steady enclosure, no drafts, stable temps. And dry materials, no moisture. Address these before slicer tweaks. They remove most visible defects. Fit. Prints match dimensions and tolerances, so parts assemble cleanly. Feel. Comfort and flexibility where the body moves or skin contacts. Finish. Consistent surface and color where it's seen. Use orientation, material choice, and post-finish to meet fit, feel, and finish. A clean, slow first layer on a steady machine prevents most failures. Verify bed level and Z-offset. Watch the first perimeter stick uniformly, and pause and adjust early if it doesn't. Fixing alignment now avoids warped corners, tangled filament or stringing, and weak adhesion later. Avoid too thin walls, breakage, messy first layers, warping, wrong orientation on show faces, support scars, and rushing prints for minutes saved. Small design changes, fillets, stitch holes, chamfers, often solve both strength and comfort. Protect show faces up to reduce scars. Hide supports on interior sides. Align strength along load paths and plan stitch or bond zones in CAD, computer-aided design, so attachment is tidy and repairable. Orientation is free strength and cleaner finish. Back hard parts with fabric or felt where they touch skin, round edges to avoid hot spots, and include stitch holes or channels in the model. Plan attachment in CAD. Don't drill later, so assembly is quick and repeatable. Beyond design lies discipline. Calm rooms, clear air, and careful habits protect the craft, the creator, and the quality of every print. Keep temperatures steady and block drafts around build chambers. Ventilate fumes, especially for resins and high-temp plastics. Separate resin stations from fabrics and finishing to avoid contamination. A calm room equals repeatable prints and cleaner post-process. Use PPE, personal protective equipment that fits the task. Nitrile gloves for resins, solvents, safety glasses for cutting supports, FFP2 masks for powders and fine dust. Label waste and keep a spill kit visible. Good habits protect people and product quality. In 3D printing, discipline defines quality. This chapter shows how maintenance turns a workspace into a well-tuned creative system. Organize 4 zones so workflows: prepare, materials, slicing, print, machines, post-process, wash, cure, cleaning, check, QC, photos, pack. Keep paths short, benches uncluttered, and tools in fixed locations. Fewer handoffs and less walking mean fewer errors. Adopt CDL, clean surfaces and nozzles. Keep materials dry with sealed bins desiccant. Log each job. Material, method, date, operator, 1 photo. These notes speed repeats, reveal drift, and prepare for compliance later. Daily, wipe rails, check beds, empty resin vats of debris. Weekly, belts, rails, light lubrication, bed mesh, level. Monthly, deep clean, replace worn parts, nozzles, FEP, filters. Small routines prevent big failures and keep results consistent. Every designer faces the question: build it in-house or source it out? This chapter explores where creativity meets strategy. Choose in-house or bureau by speed, quantity, and capability. Hybrids are common. Print in-house for one-offs and small batches, rapid design loops, confidential parts, or when lead time beats price. You gain control over color tests, fit samples, and quick tweaks, useful for trims, fixtures, and on-model trials before committing to volume. Use a service bureau for larger batches, advanced materials, colors, industrial SLS, MJF nylon, metals, or when you need documentation and process certifications. You trade some control for throughput, material options, and quality systems. In-house equals speed and control, bureau equals scale, material breadth and documentation. A hybrid wins often: prototype and pre-series internally, then shift stable designs to a bureau for batch runs, dyeing, and finishing at volume. Brief clearly. Use case, method, material finish, quantity, color, tolerances, delivery date. Request build photos and material certificates. Clarity reduces back and forth, protects timelines, and yields parts that fit on the first try. As 3D printing grows, Europe sets the pace, guiding innovation through policy, protection, and long-term vision. A quick EU policy note to future-proof decisions. ESPR, Prioritizes textiles for durability, repairability, and circularity. Design printed parts for replacement, clean disassembly, and monomaterial where practical. Offering spare parts and documenting materials supports compliance and customer trust. Avoid unverified biodegradable claims. Document materials clearly. DPP, Digital Product Passport, carries product data through life. Your simple logs, material, process family, color, batch, date, become the passport later. Good records enable returns, repairs, and recycling, and smooth collaboration with suppliers. Here's where design meets economics. Balancing creative ambition with practical budgeting for 3D printed fashions. Set budget expectations before pilots. Broadly, FDM is low cost, filament, simple post process. Resin is moderate, consumables, curing. SLS, MJF nylon, is industrial, powders, machines, bureaus. Polyjet is premium, multi-material, color. Pick outcomes first, then budget accordingly. Prototype budgets should follow the method, not force it. Before you move on, take the short quiz to lock concepts, save your notes, and continue when ready. Thank you for your attention.